Hello viewers, in this video I will show you how circuit analysis is done. Circuit analysis is an important and interesting subject in electronics. Although various tools are available these days to perform circuit analysis, but it is necessary for electronic engineers to know how to do it. So let us see how the circuit analysis is done through a simple example. As you can see in the circuit, there are 3 resistors, 1 transistor BJT and 2 power sources. The characteristic of BJT is given where beta is equal to 160, and you know that basically this is the transistor gain. The voltage between base and emitter is 0.75 volt. We are required to find out Vout, which is the output voltage of the transistor between collector and emitter. Now if you closely look at the circuit, you can see that at node B we are supposed to find out the voltage. So if we know the current through resistor, 1 kilo ohm resistor between A and B, so we can find the voltage drop at B, and then by simply applying the KVL we will be able to find the required parameter, that is output voltage. Now clearly for any transistor the emitter current is equal to the sum of base current and the collector current. So here we need to find out the base current. Now in order to find out the base current, we will have to go back in the circuit. In order to do the circuit analysis, we always require the 3 basic laws. 2 are Kirchhoff's law, that is KVL and KCL, and 1 is the Ohm's law. In any BJT, we know the values of alpha and beta, which are actually the simple ratios. Alpha is the ratio between IC and IE, and beta is the ratio of IC and IB, as shown in the figure. With the basic equation of IE, which is equal to IC plus IB, we can find the relation between IE and IB as shown, which means the ratio between IE and IB, which is equal to 1 plus beta. Now clearly the circuit comprises 3 loops, L1, L2 and L3 as shown. We will apply KVL in these 3 loops. Now before that we need to apply KCL at node C. According to KCL at node C means the sum of all currents at node C must be equal to 0, which means here in this case current I1 is divided into 2 components, one is I2 and one is base current. Now in order to find out I1, we will apply KVL in loop 1. The equation for loop 1 becomes I1 into 120k plus I2 into 240k and minus 5 will be equal to 0. Please remember that we are taking the directions of conventional current. Now let us see in loop 2. When we apply KVL in loop 2, we get VBE minus I2 into 240k equal to 0. So here in this equation we know the value of VBE. So by just putting the value of VBE, we will find out the value of I2, which is equal to 2.92 microampere. We will put this value of I2 in loop 1 equation to find out the value of I1. The value of I1 has come out to be 35.826 microamperes. We know the values of I1 and I2, which means the value of IB is simply equal to 32.906 microamperes. We know the value of beta, so we will apply in equation IC is equal to beta IB to find out the value of IC, which comes out to be 5.265 milliampere. Since we know IC, so now we will be able to find out the voltage drop between the nodes A and B. After applying KVL to loop 3, we will be able to get our required answer, and our required answer Vout across the transistor is 10.735 volt. Thanks for watching this video.